In a previous video, we went over how to create slice plots. In this video, we will show you how to create contour plots and isosurface plots in Kامسول multiphysics. Contour plots are used to visualize scalar quantities using a series of colored regions or lines. They are available for 3D and 2D plot groups and are useful for a variety of applications, including heat transfer and acoustics. Isosurface plots are available for 3D plot groups and are used to display results quantities as a set of colored surfaces on which the quantity has constant value. This is useful for showing many fields such as temperature, chemical species concentration, electric potential, and pressure. Here we've opened up a modified version of the heatsink model from the application libraries. In this plot, which we created in a previous tutorial, we have a surface plot showing the temperature change as air flows through the air domain and past the heatsink. We also have an arrow plot showing the fluid flow velocity. We can also visualize the temperature changes through a contour plot or an isosurface plot. And originally in this model, we have a contour plot showing the pressure throughout the channel, but we'll create one showing the temperature. First, we need to create a new plot group. We can do this under the Results tab in the ribbon by clicking 3D Plot Group. We could have also added this through the Results node by right-clicking to access a menu. And now to add the contour plot, we can right-click the 3D Plot Group 5 node, or we can click the Contour button in the Plot Group tab in the ribbon. And if I click Plot with the default settings, right now our contour plot is showing the temperature changing over the length of the air domain. But it's a little difficult to see clearly what's happening in the plot since we just have a wireframe version of our model geometry. To make the contours more distinguishable, we can add a surface plot. In the expression field, we can enter 1 so that we're not plotting any physical quantity, and we can change the color to uniform and gray. And if I click plot, we can much more clearly distinguish the contour lines from the model geometry itself. Now let's return to our contour plot and access some of the settings. We can see that the data for this plot is taken from the parent node, which is our plot group node. And if we select the 3D plot group 5 node, we can see that the data set is set to study1/solution1. And this is study1/solution1. In the settings for the contour plot, we have a few different options. We have different entry methods for how to create contour levels. So the number of levels is the default method, and we can enter the total number of levels we want to appear in the graphics window. Let's say we wanted 40. We can enter 40 and click plot, and then we have 40 levels in our color legend and 40 contour lines displayed in the plot. We could also choose levels to enter the temperature values for which we want contour lines, or specify a range. Let's say we wanted a range running from 294 to 373 Kelvin with a step size of 10 Kelvin. If I add this range and then click plot, we'll see contour levels for the specific range specified. And I'll set this back to how it was originally, and I'm going to return it to 20 levels instead of 40. Then under the coloring and style section, we can toggle level labels on and off to show us the temperature along each contour line. We could also use the filled contour type to create a surface plot with colored bands, like we'll see here, where each section represented has a constant temperature value. With filled contours, you can choose whether or not to fill parts of the geometry surface that are below or above the lowest and highest contours using this checkbox. And so we can see that removes a portion of the plot. Lastly, we could choose the tube contour type to use tubes as the contours in the plot. We could define the tube radius using a constant, a parameter, or an expression, and we can control the radius scale factor manually if we want to. Now I'm going to return it to having filled contours. We have a lot of different coloring options. We can change the color of the label text. If I use lines, maybe I'll change these to blue. We can choose the coloring to be either a uniform color or use a color table. And here I'll use the thermal light color table. We could also choose to reverse the order of the colors in the color table, or even symmetrize the color range. This plot really allows us to see the development of the temperature gradient along the walls of the air domain around the heatsink. I'll rename this plot group to temperature contours. And now that we've created a contour plot, you'll see how creating an isosurface plot works in a similar fashion. If we expand the isothermal contours node, you'll notice that we have an isosurface plot. These isosurfaces show constant temperature surfaces around the heat sink. Let's delete this plot so that we can create it from scratch. And to add it, we can click the Isosurface button in the ribbon. And I'll click Plot first with the default settings to see how that looks. Under the settings, we can once again see that the data set is taken from the parent node. Then under the expression, we want to leave the temperature as it is. Under levels, we have similar entry method options. So currently we're plotting 5 levels. We can see all of them if we rotate the heatsink upside down. But this looks a bit sparse, so let's double that to 10 levels. And if we select the interactive checkbox, you can move the isosurfaces either by dragging the slider or by entering a number in the shift field. I'm going to restore the shift to 0. We could also add a filter to this plot to limit what parts of it we want to see. So we can click the filter button under the isothermal contours tab. And here we can enter a constant, a parameter, or an expression. I'll enter y greater than 0 to view only our results in which the y coordinate is greater than 0. And now we can see the temperature field as we move along the length of the air domain, before, along with, and then after the heatsink. Contour and isosurface plots are convenient for visualizing many types of physics. In creating these 2 plots, we reviewed how to utilize a surface to provide a background for contours, display results using either of the level entry methods, use different contour styles available, apply any of several coloring options, and also use a filter to refine a view of your plot.